Episode record number 99, recover binary search tree. For this question, it build up a tree. It is a binary search tree except that there are two nodes of the tree are swapped by mistake. So let's write a function to recover the tree by swap the values of the node which was placed in a wrong position. Let's take an example. The first example, you see this 1, 3, 2. The correct position is 3, 1, 2. We'll see 1 and 3, they have a wrong placed wrong. And so we can swap 1 and 3. And the second example, let's see the order 2 and 3. If we swap that, we can get this one as a binary search tree. We know for binary search tree, if we do the in order traversal, those kind of values of the tree nodes will be in ascending order. We say that exactly two nodes of the tree was swapped by mistake. So that means, for example, we have this one and this one. They are doing by mistake. Then in reality, what it places is like this is going to this position, and this one is going to this position. So we'll see for the first tree node, which does not have correct position, is actually taller than its previous and the next. And for the next tree node, which is not in a correct position, it is actually shorter than its neighbors. So we can do the traversal, right? So intuitively, what we think about is that we do a in order traversal, and for example, the result is 1, 2, 3, 4, 5, right? If when we traverse, it is like 1, 4, 3, 2, 5, right? So we'll see. We can compare to find the first one, which is greater than the next. Then this is the one which placed in a wrong position. And we'll traverse again, find the first one, which is which is, for example, the previous one is greater than current one. Then the next one is wrong position. So what we need is that find the first one greater than its next. That means then the great one will be the first one which placed in a wrong position, and find the next one which has first greater than next, then the next one, right? So first taller and the next shorter. So in this case, it will find the two elements, two tree nodes, which is placed in a wrong order. So so for this question, we can have use so in this case we can do the in order traversal and have a tree node which is called current, and also use that tree node which is called pre. And when doing the in order traversal, if we find, for example, the pre is greater than current, and if we don't find the first one, then the current one is then the first one, the pre one is the first element we're looking for. And if we already find the element which is in a wrong position, then we will say we find another one, right? Another one which is pre greater than current. Then the current one will be the second element. Second tree node. Then we find the two tree node, then swap the values. We are going to use three variables. One is called the tree node, which will be called the first. And let's get it as now. And we'll have another node called the second. It will be also be now. We can have a variable called pre. Pre. And at the beginning, it will be smaller. We do the in order traversal, and the first element for the in order is smallest of the tree in the tree. So we can put this one as a minimum value. So we'll have pre equals new tree node integer dot new value. So we are do in order traversal. We call root. And when we do this in order, we are trying to find the first and second. So what we are going to do is private void in order. No. So for the in order is that you are right. This is like a DFS, right? The exit condition is that if we traverse, for example, the node is already to none, right? When we are going to exit, just return. That is and also we are going to do in order node of the left, and we'll do something in the middle part, and then do in order node of the right. Right. So here what we are going to do is that we are trying to see if there is a node of value is smaller than 3 of value. That means we just as we mentioned, we have for the in order we should strictly increasing, but this one is not placed in the correct order. So we'll say if first equals to not now, then we are going to have first equals pre, right? So the pre, the first one is which is greater than its next, means this one is in a wrong position. We are right. Here, there is one thing we need to. We cannot write else. Else, right? We cannot write else. The reason is that is that when the first is already fine, right? Then we'll have a second, right? So in one of the scenarios that the first and the second element, they are just next to each other. So if we have else, this one is ignored. For this kind of scenario, we cannot find out if the two elements are placed together. We cannot find a second element. So what we need to do is that we put the second element just as its next one. And do it in order traversal. If we can update the second one, then we update the second one. So we write if second if first equals to none, then second equals no. Then we have pre equals to, after this we write pre equals no. Doing like this, we'll find the first and second element. Then what we're going to do is that we'll have 10 equals first dot node and the first dot value. And the first dot value equals second dot value. And we'll have second dot value equals 10. Doing like this, the time complexity will be O(n). Space complexity will be constant, it will be O(1). If we do in order traversal and put every element in an array, then such the array, it will be more easy to write. But the space complexity will be O(n).